So here's an example, Cartesian point. So something you haven't seen is that you can actually construct objects interactively using object editor also. Okay? You tried it out? Okay. So you can do that. So what I'm going to do now is count the number of Cartesian points that have been constructed. I'd like to keep a count. So many cars produced, so many burgers sold, right? So I want to have how many Cartesian points were instantiated. Okay? So I did it once, so I've got my num instances to be 1. Okay? I do it another time, and now my num instances is 2. So, this is object-oriented programming. I've got objects, I'm counting objects. Okay? This is object-oriented programming. Something else I'd like to do. I'm given a point, and I'd like to go and call a method that constructs a new point given 2 existing points. Okay, so I'd like to create a point that is the middle of 2 points. So that takes 4 parameters, the x and y of the first point and the x and y of the second point. There's something else that seems, I'm returning new points, objects. So that's object programming. Okay, so I specify the coordinates of the 2 points, and I get back another point. That's what mid does, returns a point. And now I've got num instances to be 3. I've got 3 points. Okay? So, is there anything different in these methods? And so is there a difference between the method returning number of instances and other methods seen so far? Similarly, difference between mid and other methods we've seen so far? Yeah.
The num instances thing, it's not really a method that's being done on an object. It's being done on the class itself.
It's like let's go and make the analogy between classes and, what was the analogy? Instances and cars and classes and? So factories are objects too, right? You can do things, you can go to a factory and say, how many cars have you produced? Right? So that's the next slide. So I can go to a car and say, how many miles have you driven? Okay, and different cars are going to return different answers. Okay? Or I can go to a factory and say, hey, you're supposed to use imagination here. The one is a silver car, the other is a red car. Okay? And I say, I like these 2 cars. Please produce for me a new custom car. Yeah, charge me whatever you want to. And return to me a blend of these 2 cars. Okay? And again, use your imagination. That's a blend. So that is equivalent to doing what in the object-oriented world? A midpoint. Saying, here's a point, here's another point. Give me something in between. Blend. Something in between, right? And I can go to a factory and say, how many cars have you produced? Okay? So way back, we could have used for class the analogy of a blueprint or a factory. And in some sense, when I use the word factory, it's not good because we have something in Java called a factory object, which actually behaves like a class, but it's really an object instance. So now you kind of see why I went with the factory analogy, because on blueprints you don't imagine invoking operations. Okay, but factories, are more active. Okay. So here, similarly, you can go to a point and say, what's your radius? And you can go to a Cartesian point and say, which is a factory, hey, give me a mid of 2 points, and so on. Okay. So these things belong to the class, to the factory. And that's, the word static, Smalltalk called it class methods and class variables. Java calls them static because it's inspired by C++, which called it static. Static is just a way it's implemented, and we'll talk about that. But basically, these are methods that can be invoked on a class, not in an instance, but a class. Okay? And they're called class or static methods. And these are declared in the class on which they're invoked. And the keyword static is in header, and they can't access any instance variables. Okay? So okay, so this is getRadius. This is an instance method, accesses instance variables. And here's my mid. And it's, you guys can all do this. You take 4 points, four coordinates, and returns a new Cartesian point. Okay, this is a class method. It doesn't access any instance variable. Okay, and we know it's a class method. And how do you call it? You just say class name dot method. Okay, you don't have to create an instance. You just can invoke it directly on the class. And you're used to doing this. Okay, it's been magic to you, but you've been able to say math dot something. Math was not an instance. Math was really a class. Okay, is a class. Okay, by the way, so how are you going to implement num instances? And I'm sort of starting this off, but try to imagine. I somehow implemented it, right? So how would you go and figure out, how would you count the number of instances of a class? I'd have to have a variable called num instances somewhere. Yeah. You would add to it in the constructor of the class. Okay, and the num instances would be what kind of variable? It would be a class variable. Okay, it keeps the class state. It's like in a factory keeping track of how many cars are produced. Okay, so you would just increment num instances each time a new instance is created, and get number instances would be a static method, a class method. So this is our get num instances, and the returns num instances. So this is a class property now. So classes can have properties also. Okay, just as objects have properties. And what you would do is basically in the constructor, you would go and increment num instances. So this is very interesting. The constructor is called per instance. So you can think of that as an instance method. And an instance method is accessing a class method. It's like when you're driving your Corvette or your whatever, you can go and press a button to say, hey, how many other Corvettes have been produced? You have a link to the factory. There is a well-known factory. So it just goes and tells you, hey, how many, you are the nth person produced, car produced. So you can declare this to be a class variable. Okay, and let's trace the execution now. So num instances will be allocated in memory when? Sorry? When a Cartesian point is constructed, which Cartesian point? I mean, the first one? So that's more or less true. That when the class is actually, I mean, it could do that. It could either do it when the class is loaded in memory, okay, and the class will be loaded in memory when you construct the first instance, okay. But once the class is loaded in memory, the variable is there. It's not going to get garbage collected. It's there forever. And now you can see why the word statics makes sense. Because classes are statically created. They're not dynamically created. So, the static state. Okay, as long as the class is always there. And when it's loaded in memory, it will go and allocate this slot. So now in Cartesian point, you go and say new Cartesian point. It'll create new x and y coordinates for the new point. And now it's going to increment. It's going to go through this and increment num instances. Okay, so this static or this class variable gets incremented. And now you do it another time. It goes through this process again. And it increments it a second time. Okay? So this memory is just there. It just keeps that state. Okay? So hence the word static. The word static is used applies to many situations, and this is one of the situations where things are static. Okay? So instance versus class membership, class methods, members. You can have instance members and class members. Class members are class methods and variables. Instance members are instance methods and variables. And class members are visible to other class members. Okay? So one static method can call another static method. Okay? Visible to all instance members. Okay? So they're visible in constructors, they're visible in instance methods. Okay? And instance members are visible to other instance members. Okay? So one instance method can be called by another instance method in the same class. But they're not visible to class members. So why is that the case, by the way? Why this asymmetry? Why couldn't a static method call and refer to an instance variable?
It would not, theoretically, you would not know which one to call.
Doesn't make sense, right? There's no distinguished instance. So you can't go to a factory and say, how many miles have you driven? Right? Doesn't make sense. Okay? So which of 0 to many? There could be no instance, or there could be multiple instances. Should you refer, the class member refer? Okay, so let's just make sure that we understand this all. Get num instances. Can it refer to num instances? Static, static. Get radius can refer to x and y. Get num instances can refer to, can be called by Cartesian point. Yeah.
Now, if you were to go to a factory and ask them how many miles in all of your cars driven,
You still have to know. Yeah.
I mean, is there a way to do that sort of deal in Java?
So, can you go to a factory and really figure that out? Is it humanly possible?
I mean, they could have some sort of
Wireless
installed in
communication.
all their cars. You go and ask.
So you'd
Again, this is physical. I'm not sure what the correlation in Java would be. It would be
So
tricky.
you'd have to have some wireless communication going on, and all kinds of privacy issues happening.
Sure.
Right, there. So I've got a class defined here, and some guy in China has instantiated it. Can Java keep track of this whole thing? It could possibly. Okay, but then you would have to have a wireless connection each time an instance would have to sort of communicate with the class. Okay, and so you don't even know all the subclasses of a class. You just it's not, and so you don't know the subclass, all the sub instances of the class. Yeah, Marshall. Yeah, but how do you do that? I mean, I just instantiate something, in a computer that's isolated from the whole world. Yeah, but what does the constructor do? How does it connect to the class? It has to go to some central place. See, so it's instantiated. The class is being instantiated one in one computer, another computer. They're not even talking to each other. You mean within a virtual memory, within one particular program? That could be done, possibly. Okay. But within a program, you could do that. Okay, it's every time, but it doesn't actually provide that facility. Okay. But to really answer the question right, you would have to know all instances of the class in any memory. So that becomes more tricky. Okay, let's just go and finish this off. So I can refer to num instances and get num instances, but I cannot refer from get num instances to x and y. Okay, because they're instance variables. Okay, so we always, you always say public static final double bounds, and you want to declare a constant. I mean, Java makes you write so much. Public static final, right? So why do you think the word static always happens before a constant? It's never going to change, and so you might as well put it in the class. What if you don't put the word static? What do you think Java would do? Yeah. Yeah, it's going to do that. So you say new another BMI spreadsheet. You can say another BMI spreadsheet dot pounds in kgs. Okay, so you're used to doing this. And if you did not do that, you just said final double. It's going to create a copy each time. I mean, I think it'll do that. It shouldn't. It should just cheat and say, I'm just going to create one constant. You'll never know the difference in the behavior. Your objects will be skinnier, but you'll never know the difference because you can never change it. So, this is what I think it does. It used to do this. It probably still does it. It's getting better about optimizing memory. So yes, that's a difference. That's why you have to put the word static. But I personally don't like that. I think you shouldn't have to put the word static, and it should automatically make it static because it can't change. Okay? And if you say pub, and the reason why you don't want to do this is that if you want to refer to the constant, you've got to say new another BMI spreadsheet dot pounds in kgs. You can't just say BMI spreadsheet dot pounds in kgs. So it's to refer to the constant, you've got to construct an instance and then say. Okay? So, constant should be class constant, only one copy and easy to refer to. unless there's some good reason for hiding named constants from static methods. Okay, now given the rules, I can make my mid as either a class method or an instance method. The rules allow me to do it either way. I can create this as an instance method. So what do you think I should do? Create it as a class method or an instance method?
Well, if you were wanting to use it, if you had a group of points and one of these mid points for all these various points, and then you go out and delete one of the points, and you still want, and then you go back and try and recalculate the midpoint, if you deleted the one class that was keeping track of where the midpoint was, you'd have to find a new class to keep track of it. Otherwise, you just use the class type itself to calculate this midpoint.
Okay. So the point, mid is taking 4 coordinates, right? Mid is not saying there's some implied set of points. And I'm trying to find some midpoint that's equidistant from all of the points. Okay? Yeah, Preeti?
Would creating it as an instance method violate the before least privilege? Is it unlocking access instances?
Actually, that's a very good point. Okay? That you meant for this mid to only look very nice at these coordinates, and you happen to have an x somewhere there as an instance variable, and your mind is wandering, it is so simple. So you forget to put the 1 here, and you go and access that x. By doing it static, you are making sure that it won't access some instance variables accidentally. Okay? So it's an excellent answer, which I didn't think of. Okay? So my argument was much more sort of a laziness argument. Okay, that if I want to call mid if I made an instance method, then I have to first create the instance and then call the mid method on it. So it's, I got to create a car just to figure out, how many cars have been produced from the factory. Whereas I might as well make that a factory method and go to the factory and say, I'd have to say new math.round 5.7. Just, rather than just saying math.5.7. Okay, so I did think of it. Okay. So instance method has all the privileges of a class method. Any class method can be made an instance method. Bad style to have instance method that does not access an instance variable. They belong to the class. They violate the least privilege principle and require needless instantiation. Okay. And so class versus instance constant method. Named constant should be static. We saw that. And methods not accessing instance variables should also be static, unless they need to be listed in an interface. So I'll just talk about the interface later. For Java does not allow a class to have a class interface. So the static methods cannot be declared in an interface. Okay, and I'll talk about that. Oh, so these slides should have been in opposite order. So cannot define interfaces for classes. There's no conceptual reason why not. Okay, in fact, before object-oriented programming came around, everything was static. Everything was a class method. And these classes were called, anybody know? So you guys have dealt with languages that are not object-oriented, right? Some of you have done it. So what is the equivalent of a class in that for anybody who has? What's the word used? Sorry? Modules. Okay? And modules had module specifications and module implementations. In fact, this whole idea of interfaces came into object-oriented languages from that. Okay, so there's no conceptual reason why not, and I don't like this design feature. But basically, like I said earlier, when I was giving you very simplistic arguments, using static means non-object-oriented programming. Okay, that was somewhat simplistic. And if you believe that, then you say, why encourage people? When you're doing something bad, which is using static variables and methods, why give them something good? I mean, you're already bad, so continue being bad. 2 wrongs are equal to 1 wrong. Okay? Something like that. You cannot use super in methods, in class methods. Does that seem Unreasonable? What would it mean to, supposing, so I've got class B that inherits from class A. Yeah. So yeah, I'm extending both. So I say class B extends class A. I inherit all the instance members. I inherit all the class members. Now in class B, I've got a class method, M, that wants to call an M in class A. You can't do super. So what can I do instead? I can override it. I can override it in some, yes. When, I can always have a new M, but I can't say super.m there. Yeah.
So you just call the method from the other class.
I can just say a.m. I can just say a.m. In fact, if B extends A, if C extends B extends A, in C I can call a.m. Okay, so which you couldn't do with instance methods. You couldn't do super.super, but you can do that here because you've got a very well-defined name there, and you can just call. Okay. We'll talk about dynamic dispatch. So we'll see that there's no dynamic dispatch with static methods, hence the word static. Okay, so we've seen this analogy, and like I said, blueprints as classes would not have modeled class state and operations. So my general structure is class variables, instance variables, class methods, instance methods. Okay, that's what we do with the Cartesian point, right? Cartesian point has some instance methods, and it has some class methods and variables. Okay? And the class integer is an example of that also, where you have static max value and you've got some internal variable value that keeps the int value. You've got the int value that will return that, and you guys are used to parse int as a method you call an integer. Okay, just ignore this prompt here. I'll try to remember to delete it. Can you imagine having a class with no instance members? That's not what integer is. That's not what a Cartesian point is. But does that make sense? I mean, using analogy, you have factories, factory methods, factories produce instances. So in our analogy so far doesn't accommodate classes with no instance members. But does that make sense? Yeah.
I mean, it's having a subclass where the superclass has three bodies, which means it technically does. You wouldn't see any in the actual body of it.
So you're saying such a class should always be a superclass of some other class.
Yes, or it's a static class.
Okay, so what does that mean for it to be a static class?
A whole class has no, it becomes more a module because of an object.
Becomes a module. So what would be the real-world analogy? Our factory analogy is not working. What would be a real-world analogy for something, for a class with no instance members? Office, okay, or using cars. So creating instances is meaningless now. So example of a Java class like that. Well, let's first look at an example of a Java class like that. So math, you only used methods in it, and some methods actually depend on some static finals. Okay, so there are some constants here which are static, and your log depends on this constant. But some variables, some methods do not depend, and you could easily imagine modified math. My slides are a little off. I'm giving you examples of things with both static and int. And now let's go back to the question I was answering. Office or a car dealership. Okay, you can figure out try to figure out how many cars the dealership sold. That seems like a reasonable question to ask. Or an office where you don't really produce something. So there is an analogy there. And an example of a class like that with only class methods. Okay, I guess my slides were right there. That both math and system were examples of classes with only class members and no instance members. Okay, so there's a lot of things I'm trying to do and I lost track. So now can you figure out a class with only class methods and no instance variables? Would that make sense? Yeah, Marshall? Those classes? Okay. And they don't have, they normally don't. Math, I could imagine, math is this big humongous class, and you can imagine dividing math into subclasses, into different classes, and having some methods like double, which don't depend on any instance methods, any variables. Okay, so we've just cluttered a lot of things into math, and the math could easily have been broken down into things. So just a pure function, and real world analogy would be a service center. Okay, so office has state, dealership has state. How many cars? Service center you can imagine having state too. But assuming there's nothing stored, there's no products there, and you just go and wash the car, pure service. Okay, no state. So this is the best analogy I can come up with, and you can imagine that to be such a class. There'd be such a class. Can you imagine a class with only class variables, no methods? That's not a bad class. We know we can always make things public. Yeah.
Like a data warehouse, you just have the data and you don't have anyone really doing anything with it, or a server farm.
But data warehouse, server farm becomes to a computer thing, and we don't quite know what that means. But data warehouse, you're saying you're making it a public variable. Okay? As long as it's static, it's somewhat safe. Otherwise, anybody can come and change it. And we don't want a data warehouse doesn't want things to be changed. That's why you want to have these methods to guard access to the method. Okay? But the best analogy I can come up with is in system. So this is an example of such a class that you might have. That system. You guys have been saying system.in, system.out. Okay? These are just class variables, and these are final variables. So you can't go and change them. Okay? It so happens that there's also system.exit and system.current time and mills, which has nothing to do with these variables. It's just Java being lazy and not providing too many classes. So again, if it was more modular, it would have, a different stream class. It would go and basically have just these variables. They're a constant, and you don't have to worry about having any class methods there because they're constant. And the analogy I came up with was, you can go to a petrol pump and use the air. That's free, unguarded by any method. But because you can't just take it away, it's like a final variable that stays there. You can't modify it. So you can imagine this. Okay, one of the questions that you'll come up with is that you've got some state and associated methods. Should you make that class state, or should you capture that in a class object or an instance object? So what are the criteria? When should you make some state, instance state, and when should you make it a class state? This is a decision you have to make. And in your next assignment, I tell you, the position where the next chat message should go, put that as static state. Now, I don't think that's a perfectly good idea. I want to give you some practice with using static methods. And you can say, wait a minute, that's not a good idea. It should be an instance state for the following reasons. So what reasons would you go and give me to say that, no, make this an instance state rather than a class state? Yeah. So when you want multiple copies of that thing, okay? So if you want multiple independent instances of that state, then you can make a class object. Okay? If you don't want multiple, then you make it class. Okay? And you do not need interfaces or dynamic dispatch, so you don't need certain things that. So system.in is an example. Okay, there's only one input stream. You're not going to have multiple input streams. There's only one console. So you're going to make that a class state. Okay? You can have things called singleton classes. What do you think these classes mean? Yeah? Exactly one instance. Okay? And why did you ever create such a class? Because maybe you want interfaces, maybe you want dynamic dispatch. Okay? So you do have that. So that's a necessary condition, not sufficient. So let's just understand this clearly. If is the McDonald's class object or an instance object? It's a franchise. Okay? So you have multiple people following the same rules, so you would make that. Analogy is never perfect, obviously. Every McDonald's can look different, and this one looks different. But even the prices can be different. Even what they offer can be different. Okay? But there's some set of rules. And a mom and pop store. Okay? And here's the danger. Okay, you say, oh, I'm going to just create this as a class object. I'm just one-off. I'm not ambitious. This is not very popular. And, later they become so popular that you sort of say, hey, make this a franchise. Okay, similarly, I tell you guys to go and choose the the chat message position to make that a static variable. But what if you want multiple scenes? Okay, it won't work. So as a program, as objects, class objects are often converted to instance objects as program becomes popular and evolves. You say, oh, this is such a cool thing. I want to have multiple bridge scenes at the same time, okay, if it makes sense. So when in doubt, make it an instance object, but it is easier to make things into a class object.